Welcome to Module 5, Lesson 6. Today we're figuring out the volume of composite figures, or in other words, figures that are made up of more than one rectangular prism put together. For this first problem, and for all these problems, the key really is organization. So I'm going to start by labeling each of these rectangular prisms. And I'm going to start with rectangular prism A, and I need to figure out all three dimensions of it. This dimension is given. It's 8 meters. The next thing I need to figure out is the depth, and it says here that this whole figure is 3 deep. So all these dimensions are all 3. So this dimension is 3 meters. And then the height is something I got to figure out. It tells me the entire height of the entire figure is 12, but I need to know this. Well, they also told me that the height of the bottom figure is 6. So if this is 6, 6 plus what is 12, this has to be 6 also. I want to point out that this is not 6 because it looks like it's the height of this. We're not eyeballing this. We're using math with precision. If that is 6, this must be exactly 6 to add up to 12. So the volume of my first figure, A, is going to be 8 meters times 3 meters times 6 meters. And that's equal to 144 meters cubed. The volume of prism B is going to be, in this case, all three dimensions are given already. I have 6 by 10 by 3. 6 meters by 10 meters by 3 meters is 180 meters cubed. And if I add those up, volume A plus volume B is going to give you my answer. 144 plus 180 equals 324 meters cubed. This next problem is a little bit more complicated, but we basically have two shapes. We have the larger shape, which I'm going to call A, and we have the smaller shape, which I'm going to call B. Now the volume of A, they tell me, is 9 by 8 by 18. So it's going to be 9 inches by 8 inches by 18 inches. And after I do that multiplication, I get 1,296 cubic inches. Volume of shape B, they tell me, is 13 by 8 by 2. Or 208 inches cubed. Now as I look at my figure, I see that I have two of the shape A's, here and here. So when I'm going to need two groups of 1296, and I have 1, 2, 3, 4, 5, 6 of B. So I'm going to need 6 groups of 208. So after I do that math, I get 2,592 plus 1,248. When I add those two together, I get a total volume of 3,840 inches cubed. You can see I made this much easier by organizing myself. Okay, in this next problem I have a tank filled with water and oil, and of course I don't mix, so things are separated out. It said that my base area, so my area of the base is 24 cubic centimeters, and the oil and water together is 9 centimeters high, and this is the oil and this is the water. So I can figure out this dimension. 4 plus 5 centimeters is 9. They want to know the volume of the water. Well, water is just going to be volume equals the base times height equals 24 centimeters squared times 5 centimeters, which gives me a volume of 120 cubic centimeters. Of course, we know that would also be 120 milliliters. But that is the answer to this question. My last problem, if you're paying attention, isn't too bad. It says the combined volume of two identical cubes is 2,000 cubic centimeters. What's the measure of one cube's edge? So if I were to draw that, this is what we'd look like. The whole volume is 2,000, which means that each cube must be 1,000 centimeters cubed. Now, some of you might think, oh, I don't have enough information to find what one side is, one edge. But this is a cube, and we know that in a cube, all three dimensions are equal. So I need something times something times something to equal 1,000. And that something has to be the same. So maybe we can call it S for side. So what is a number times itself that's 1,000? Well, the only number that works for that is 10. So each edge must be 10 centimeters long. And that's the end of today's lesson.